So this is all great, but now we need to be able to determine a winner. So let's delete this out, and let's write a method called determine winner. And what do we need to determine the winner? Well, we need to know what the user's choice was, and we need to know what the computer's choice was. So this is the signature for what our method should look like. And again, I'm just going to generate that method, throw it down here, and there's only three possibilities here: a win, a loss, or a tie. The easiest one to check for is a tie. If the user choice is equal to the computer's choice, then let's add 1 to our ties variable, and let's print out a message to the user. Console.WriteLine, you both picked this one, you tied. And remember that user choice and computer choice are just single letters. I would like to use my conversion method to print out the actual full word of the user choice to the user. So let's use our convert choice to word method and pass in the user choice. So this should say, you both picked paper, for example, you tied. Otherwise, let's check to see if the player won. And there's 3 ways that the player could win, and we're going to have to list them out for the computer. So this expression is going to be a little more complicated. The first condition is going to be if the user picked rock and the computer picked scissors. Or if the user picked scissors and the computer picked paper, or if the user picked paper and the computer picked rock. If any of those 3 things happened, then the user won. So we're going to say wins, add 1, and then we're going to print out a message to the user, something along the lines of, you picked this, and the computer picked that, you win. And let's convert both of those choices to their words. So we want the user choice, and we want to also convert the computer choice. If neither of these things happen, then the human lost. So we'll say losses, add 1. And then we'll print out our loss message. I'm just going to copy this line from above because it's very similar, except we're going to say here, you lose. Just like that. So again, let's run our application and see what happens. Rock, paper, scissors. I'm going to choose paper. The computer picked scissors, and I lost. Well, let's play again. Rock. Computer picked paper. I lose. How about scissors? Hey, I finally won. So it's moving along now, but there's 2 things I don't like about this. First is that the screen is really busy. We're never clearing the console screen, so all the games are starting to run together. And the second is, according to our flowchart, we need to be able to print out the score. So let's go ahead and do that. Let's print the score after we determine the winner. So let's create a method called printScore. And because our score variables are fields in the class, we don't need to pass in any parameters. I'm going to generate my method stub, printScore, and let's just print a blank line. And then let's print out our wins, losses, and ties. And when we print the score out, I'd like to put a little, let's put that down here. And when we print the score out, we'll print another blank line. And then we'll just say, press enter to continue. Just like that. And when we're going to prompt the user again, we're going to clear the console to keep our screen nice and clean. I think we're about done here. Let's give it a shot. So enter your choice, rock, paper, scissors. I'm going to say rock. Ah, we tied. Press enter to continue. Scissors. We tied again. How about scissors again? Ooh, we're both picking scissors. And then I finally won. So this is working really well. It prompts us every time. The computer picks something, it determines the winner, and it gives us our score. And then when we're done, we can hit quit. So we've successfully completed a pretty complicated application. We've put all of our code into the rock, paper, scissors game class, and we've used methods to separate out our logic. If you look over these methods, you'll see that each method has a very specific job to do. Methods do not typically do more than one job. This is called the single responsibility principle. We want each method to do one thing, do it well, and to be named such that any programmer who comes along can look at it and kind of understand what it's doing without having to read through all the code. Outside in our program, our class interface is very simple. All you have to do is call play. And that's kind of what we're going for with classes. We want to hide the complexity of what we're doing so that other people, like this main method that want to use our class, have a very clean and simple interface.